Okay, here I would like to go over homework 3, number 30, part A. Alright, so here I would like, we need to figure out how many years it will take $1,000 to grow to $1,700 if it is invested at 3%, and part A is compounded quarterly. Alright, as you can remember, the compound interest formula is future amount A is equal to initial investment P times quantity 1 plus annual interest rate R divided by the number of compounding periods per year raise it to the M times T's years time. Alright, so all we have to do is kind of identify what's given and try to solve for T. Alright, so let's find A. A is a future amount, so it's 1700, which is right here. So I'll just plug it in. So it's 1700. Alright, then initial amount is 1000, so you start with $1,000, so it's going to be 1000. Then you have 1 plus, right? Annual interest rate is 3%. So in decimal, so that's 0.03. Alright, then M is, since it's compounded quarterly, which means that 4 times a year, so M is 4. Right, then you have 4, and T is the only unknown, so we have to find that. Alright, now, so we have to isolate time T. So first thing we do is try to get rid of 1000. So I'm going to divide through both sides, divide through by 1000. So divide the left hand side by 1000. Then I'll divide the right hand side by 1000. That way I can get rid of 1000 on the right. Right? Then you can see that, let's see, so there are 2 zeros here, 2 zeros here, and the 2 0 cancel out. 17 divided by 10, so it's easy enough. So I'm going to just write it right here. So it's a 1.7. So 1.7. Right, this side it's going to be 1 plus 0.03 over 4. What's 0.03 over 4 divided by 4? Right, we cannot squeeze in, no 0 in 0, and 0 still 3. This you can't squeeze 4 in 3, so break down 0, so 30. So you can squeeze 7 4s into 30, so 4 times 7 is 28, and 30 minus 28 is 2, and bring down 0. Then we can squeeze in 5 of those, so 4 times 5 is 20. Alright, so this way it's divided, so there's no remainder there. Alright, so you can see that it's going to be 1 plus that, so it's going to be 1.0075 raise it to the 40. Alright, then we need to isolate 4t, which is sitting as a power. The easiest way to do is take the natural log of both sides. So we take the natural log of the left hand side here, and take the natural log of the right hand side also. Alright, so using one of the properties of natural log or log, we can put this power right here, 4t, right in front of natural log. So we can rewrite this guy as 4t natural log 1.0075. All right. All right, now all you really have to do is isolate t by simply dividing by 4 and dividing by natural log of 1.0075. So let's see. All right, so we're going to have to divide both sides by 4. 4. All right, divide by 4. So this way we can cancel out 4's here. Then we divide both sides by natural log of 1.0075 here, and natural log of 1.0075. Right, so this way you can cancel natural log of 1.0075. Right, now t is isolated, so we just have to find a value. So therefore t is equal to, alright, so it's a natural log of 1.7 divided by 4 times natural log of 1.0075. Right. Unfortunately, I cannot do this in my head, so I have to rely on a calculator. So I'll just use a calculator. It came with the computer. Alright, so here's the calculator. So what we need to do is we need to compute. Let's see, maybe we can see both. Let's see, yep, that. So we need to compute 1.7 with the natural log, so natural log of 1.7 and divided by, alright, you're going to have 4 times natural log of 1.0075, so I have to put the natural log with that, then close parentheses, right, then you just have to say equal to. Alright, so you can see that the t is about the 17.75. So, okay. So it's about 17.75. And the unit is in years. Alright, so this is how you do part A, and I'll do part B in the next video. I hope this was clear.